Hi everyone, I'm T. Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS, Rajalakshmi College of Arts and Science, Coimbatore. In this lecture series video, we are going to discuss about small sample test, that is t-test from quantitative methods for management. So what is t-test? The t-test is used to compute or compare the mean of two groups. The hypothesis, its hypothesis test is to determine whether a process or treatment actually has an effect of the populations of interest or whether the two groups are different from one another. So the null hypothesis is that true difference between these groups means zero. That is, alternative hypothesis is that the true difference is difference from finding the confidence interval for population mean when the sample size is small. We use t-distribution. It is discovered by William Coset under the nickname of student. Hence, it is called student t-test or student t-distributions. Okay, when we use a t-test can only be used when comparing means of two groups. What type of t-test should we use? When choosing a test, we will need to consider two things. One is whether the groups being compared come from a single populations or two different populations. Second, whether we want to test the difference in a specific direction. So computation of test statistics or t-values. The t-test significance of a mean of small sample is n is less than 30. Then you apply t-test. The test statistics formula is t is equal to x bar minus mu divided by s by root of n minus 1. Here, x bar is sample mean mu is population mean, s square that is variance is 1 by n minus 1 into sum of x minus x bar the whole square. So it follows the t distributions with n minus 1 degrees of freedom. So we conclude the calculated value is less than the tablet value at the n minus 1 degrees of freedom. The null hypothesis H naught is accepted, otherwise H naught is rejected. So we apply all this in a single problem. Now we discuss a problem. A type of insecticide, insecticide is filling in bags using a machines. A random sample of 10 bags were selected and their weights in kilograms are given below. 50, 49, 52, 44, 45, 48, 46, 45, 49. Can we assume this sample has taken from the population mean of 50? We check it. Solutions. First, we form the null hypothesis. Null hypothesis H naught is equal to the population mean is equal to 50 kilograms. Average weight of the filled bags 50 kilograms. That's all. So alternative hypothesis is not 50 kilogram. That is two-tailed test. So level of significance alpha is 5% level. Okay, first we form X. X is given data 50, 49, 52, 44, 45, 48, 46, 45, 49, 45. The total value become 473. So first we calculate the average. The average is sum of all the data divided by number of data. Sum of all the data is 473. The number of data are 10. Therefore, 473 divided by 10 is 47.3. That is average. Now we calculate the variance, that is 1 by n minus 1, it's sum of x minus x bar the whole square. Using this average, we calculate the deviated square value. So 50 minus 47.3, the whole square is 7.29. 49 minus 47.3, the whole square is 2.89. 52 minus the average value 47.3, the whole square value is 22.09. And 44 minus for 47.3, the value is 10.89. 45 minus 47.3, the value become 5.29, so on. So the total value is 64.1. Substitute all the values in this variance formula. The 64.1 divided by n minus 1. N is number of data 10. So 10 minus 1 is 9. Therefore, 64.1 divided by 9 is 7.12. So the test statistics value, substitute t is equal to the t test is x bar minus mu divided by s by root n, or it is root of s square by n. We take anywhere. So it is 43.3 minus 50 divided by root of 715. Already we found that substitute value here divided by n, or sometimes it is n minus n. When you just take it is the value become minus 3.2. But test is always positive, therefore it is 3.2. Okay. So the tablet value of T at 9 minus n minus 1 degrees of freedom, that is 10 minus 1, 9 degrees of freedom from the T table at 5% level significant value is 2.262. Since the calculated value of T is greater than the table value, therefore the null hypothesis H naught is rejected. So from this we conclude the average weight of the bag is not 50 kilograms. Now we go to discuss the second problem from this small sample t-test. A soap manufacturing soap sales soaps through retail shops. Before advertisement, the average sale of soap in a shop is 140 dozens. After advertisement, a random sample of 26 soaps is taken and the mean and the standard deviation is 147 dozens and 16 respectively. Can we say whether the advertisement is successful? Okay, we check it. Solutions they're given. The n number of subs are 26. The average is the sample average is 146 dozens, and S is 16. Null hypothesis H naught is equal to mu is equal to 140 dozens. There is no increase in sales of soaps by advertisement. The alternative hypothesis H1 is mu is greater than 40 dozens, 140 dozens. Uh, that is the right-tailed. Level of significance alpha is 5% level. So computations of T statistics, yeah, T is equal to x bar minus mu divided by S into root of n minus 1. So x bar is 147, mu population mean is 140, and yes, that is a variance value is 16. It means standard deviation is 16 divided by root of n minus 1. So 26 minus 1 is 25. So after reducing the value become 2.19. Yes. Tabulated value of this t for n minus 1 degrees of freedom, because n is 26 minus 1 is equal to 25 degrees of freedom at 1% level value is 2.060. Since the modulus t value is greater than 2.06, therefore the calculated value is greater than the table value, so we reject the H naught. So from this we conclude that the sales of soap would be increased through advertisement. Thank you.